Alright, so today is primes and composites. And what do these mean? What does the word prime and what is the word composite? So before we start that, let's review the word factor. Oh, we got a little spacing issue here, but it should still work. So if you have the number 12, we know that 6 and 2 are factors of 12. 4 and 3 are factors of 12, and 1 and 12 are factors of 12. You could also say 12 is the product of 6 and 2. 12 is the multiple of 4. Or 12 is a multiple of 3. We can also say 12 can be divided by 6 and 2. 12 is divisible by 6 and 2. These are all different keywords that you can use just by basing that two numbers are factors of a product. Alright, but for today, we have prime and composite. And what prime is this? It's a counting number other than 1 with only 1 in itself as a factor. As factors. So what does that mean? Well, if you look at 3, factors of 3 are 1 and 3, and that's it. Nothing else is going to divide 3 evenly. It's just 1 and 3, so we call 3 a prime. Same with 7 and 5. These are primes. Composites. Composites are counting numbers other than 1 that is not prime. So if it's not prime, it means you have to have a factor other than 1 in itself, because that's our definition of a prime was only 1 in itself as factors. Alright, so composites, you just have to find another one. So like 4, we already know 4 times 1, because 1 times anything will give it that number. It's our multiplicative identity. And what other two numbers will give you 4? 2 and 2. This right here, this is our reason 4 is composite. It just has to have a number other than itself as a factor, other than itself and 1. So like 9, 1 times 9. 3 times 3, composite. 24, we got a lot for 24. 1 times 24, 2 times 12, 3 times 8, 4 times, a lot of different numbers that will go into 24. So 2 goes into 24, 3 goes into 24, 8, 12, 4, and 6. That means 24 definitely is not prime, it's composite. Alright, so what we have to do is come down here and we're going to find all of the primes from 1 to 100. Well, that's a lot of work, right? No, that's not too bad. So here's what we have. We know 1, definitely not prime, because it's 1. It has to be a number other than 1 or greater than 1. Alright, 2. 2 is composite, so let's circle it. But now, 2 is prime, so circle it. Now, anything that has a 2 in it has to be composite, like 4. 4 has a 2 and a 2, which means 4 is composite. 6 has a 2. Every other number, because they are all even, they have to have a 2. So we can come through here and cross all of these off. Make it a little smaller here so we can see this all. There we go. We can cross all of those off. And so we just cut half the numbers. So we know that half of these numbers are possible primes. Possible, not our primes. And we're going to just keep continuing this until we find all of the primes from 1 to 100, because those are very useful numbers. Alright, we know 3 is prime because it's 1 and 3. But now anything that has a 3 in it, like 6 or 9 or 12, every third number is going to be composite. So just count out 3, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, count it off there, 66, 69, 72, 75, 78, 81, and then another 3 is 84, another 3 is 87, 90, 93, 96, and 99. So we just cut a bunch more. We just keep moving this on. 5 is prime. Now anything with a 5, so we know that anything that ends in a 5, which is all of these, and anything that ends in a 0, which is all of those, from 10 to 100, are composite. Now 7 we know is prime, but anything with a 7 And this is the last number we have to check, and I'll tell you why in a little bit. So 7, so we get 14, 21, 28, already got it, 35, 42, 49, and then plus another 7 would be 56, 63, and then 70, 77, another 7 would be 84, 91, you think, wow, it goes into 91, yep, and then 91 plus 98. All of these numbers here that are left are prime. And we can circle them all. You're like, wow, why don't you have to check 11? Well, I'll tell you in a second after I get all of them circled. And you want to save this sheet because primes are very, very, very important. That's why we just found them all. Why spend all this time for nothing? They are very important, very useful numbers. All right, so what it is if you have a square root of 100, you get 10, which means all we'd have to do is to find out if a number is composite. You don't have to check the numbers, the primes that are less than 10. Because what happens is anytime you have a number, it has to be made up of a small number, large number, small number, large number, and then in the middle, it's possible to get that perfect square root. But on one side, it's going to be less than 10. On the other side, it will be greater than 10. In both directions. See, if we just keep flipping, it's 250, 425, 50, 20. This is for 100. If you want to test and see if 100 is a prime number, you would have all of these factors. So we know it's composite. But in order to determine it, you would just have to check the primes that are less than 10. Which is 2, 3, 5, and 7. So if you want to determine if any of these numbers are prime or composite, all you would have to do is take the square root and whatever number it gives you, just test the primes that are less than that number. So for example, let's just say that we want to test and see if 133 is a prime or a composite. So if you take the square root of 133, where's my square root? Right there, 11.53. So that means we'd have to test the primes up to 11 to determine if it's composite or prime. So let's test it. We have 133. Our first prime is 2. Does 2 go into it? No. 133 divided by 3? No. 133 divided by 5? No. 133 divided by 7? Yes. Right there we know it's composite. It's 7 times 19 gives us, wait a minute, did I enter that correctly? 133 divided by 7, yes. 19. Okay, just double checking. 7 times 19 is 133. So it is a composite number. But all we'd have to do is check up to 11. If 11 did not go into 133, then we'd say it's prime. So if you want to try another, here, let me just make up a random one. 123 this time. Hope that's going to work out. Let's try 127. 7. So again, we'll check it with the calculator. 127, we already know 2 doesn't go into it, but we'll do it anyways. 127 divided by 3? Nope. 127 divided by 5? Nope. 127 divided by 7? Nope. What number do we have to stop at? Let's find out. 127 square root 11.26. So the prime that's less than 11.26 is 11. So 127 divided by 11, 11.54. That's it. This is a prime. You don't have to keep testing every single prime. See, a number is made up of one distinct product of primes. And since 11's our midway point, then it'd have to be small times large. And it would have to flip-flop. So if we check 2, no. 3, no. 5, no. 7, no. 11, no. That means we don't have to test any larges because it's just going to flip-flop later. We've gotten the smalls, they didn't work, nothing's going to work. It's a prime number.